Okay, so my first video is the absolutely most simple version of completing the square to get a problem into vertex form. So I do think we should take a look at something that's a tiny bit more complicated when there is some kind of a leading coefficient. So let's just go ahead and take a look at a very, very slight change of complexity where the leading coefficient is still kind of a 1, but it's actually a negative 1. So suppose we were looking at this story right here, and we wanted to get that into this really beautiful form where it is a times x minus h squared plus k. That's known as, again, vertex form, because as soon as we find h comma k, then we could just take our 1, 3, 5, 7 pattern and multiply it by a, which in this case would be -1, which would mean I would go down over 1, down 1, and over 1, down 3, etc. And I could very quickly sketch a parabola as soon as I know what h and k is. But I don't know that yet. So let's go through how we would find that. Now, there's a couple of ways to do that. So the first thing that I personally like to do is I like to group the x's together and kind of expel the non-x's. But you'll notice that since this x squared had a negative sitting in front, I factored that negative out in front. So, but then if I distribute it, I'd still have a negative x squared and I'd still have a -8. So it's still honoring what I had in my problem. Now, one of the things that we want to remember is we always have that same step that we do when we complete the square. We take this term right here and we cut it in half, which gives me the number 4. And then we square that number, which gives me, of course, 16. So I have a plus 16 right here. Now, keep in mind, I can't just put a 16 in the problem because I want it. It wasn't there, so I have to do something to balance that. But if you pay close attention, this really wasn't a positive 16 with the distributive property in play. That was actually a negative 16 that happened. So I would want to add 16 to both sides to balance that story and make sure that it works, okay? So notice that if I distributed this, I would still have my negative x squared. I'd still have my -8x. I'd have a negative 16, but also a positive 16 that would cancel, and I still have my 5. And we now have our story and we're ready to go because I know I have now created a perfect square where this is x plus 4 squared. So it looks to me like my vertex would be at -4, comma, positive 21, and it should extend down using a 1, 3, 5 pattern. So I think we should go ahead and take a look at that and make sure that this actually makes sense with how we have set this thing up. Okay, so let's look over here at my Desmos. And so we just found that we should have had a vertex at -4, comma, 21. It's kind of high. And I'm going to go ahead and label that. So let's see, -4, comma, 21. That's way up here. And my equation was y equals -x squared. Let's see, minus 8x plus 5. And so looks like because I hit a 7 there, didn't I? That should be -4. Okay, so it looks like my vertex was right, but we can also double check and make sure that if we take the time, and it doesn't take long, and we type in the formula that we thought we created and put that plus 21 at the end, if we have done things well, it should land right on top. And you'll notice that we did. And you can see the 1 go over 1, down 1, over 1, down 1, 2, 3. You can see that our pattern works. Okay, so we'll go ahead and look at one that's even a tiny little bit harder than that. So I only wanted to do 2 problems on this particular video, okay? So what if instead we had a number that wasn't a 1 of any kind? Maybe it's a 2. It could be any number that I wanted, though. So imagine we had this guy right here, 2x squared plus 4x minus 1. Now, a lot of students are going to tell you this is one of the hardest kind of problems to do, but it really is not particularly difficult if you follow the meticulous one by one steps. So the first thing that I want to say is never let anything be attached to that x squared. Nothing directly attached to x squared, okay? So the first thing I'm going to do is I'm going to pull the 2 away from that x squared, which means I'm going to have 2x, okay? So that's my first step. My second step is cut in half and square. Now, that's actually the same thing that we've been doing over and over and over again. But I always do this with a different color just to make sure that I'm being careful. If I take this 2 and I cut it in half and cut it in half, I'm going to get the number 1, right? Now notice that I just wrote down what I got when I cut it in half. So if I cut this in half, I get 1, and if I square that, I also get 1. Now, the distributive property still says that I have 2x squared. I still have 4x. But now I have this 2 sitting right here, which was not in my original problem. So what I'm going to do is I'm going to balance it by taking 2 away. So notice that the 1 is exactly what I had right here. No change. This is really a 2x squared. This is really a 4x, right? But this 2 was not in my original problem, so I had to make sure I did something to balance it. And now we're done with the problem, which is why I always think that people that say this is so hard, they're just not really paying very close attention. This is x plus 1. We're done. Remember, this number is half, just like 8 cut in half was 4. We always have that. So I'm going to have a vertex sitting at -1, -3. And my 1, 3, 5, 7, 9, whatever, I mean, it goes on forever, pattern is going to get multiplied by 2. So that makes it really, really easy. But let's just say, for the sake of argument, that say on the test, you knew you were just really struggling and you couldn't remember how to complete the square. And sometimes it's helpful to remind yourself how to do things if you knew how to get the answer in a different way, so you know at least what you're looking for. So first off, we know we are looking for this version of a story. Now, I already know that a has to be 2 because a is always the coefficient in front of x squared. So I already know I have a 2 sitting right here. Now, the second thing I want to know is, what is h? Well, as it turns out, h is the line of symmetry, which turns out to be opposite b over 2a, which is a little formula that we have done before. So the opposite of 4 is -4. 2 times 2 is +4. So I got -1. So I just found that the h value is -1. So if I do minus -1, I got a +1. Hey, we got it. Now, the only thing I haven't figured out yet is k, but all I have to do to find k is we go ahead and plug in, for all of the x values that we have, a -1, and again, that -1 comes from what we got when we found h. Now, -1 squared is 1 times 2 is 2. 4 times -1 is -4, and a -1, I got -3. So this is k. K is -3, and this says let's add that -3, and you're going to notice that we have the same answer. So this is a different option that could work if you have a problem that appears to be fairly complicated for you, okay? So I will see you guys back in class. Have a good one. Bye-bye.